Hello all. Good morning, good afternoon, and good evening. My name is Yuvraj Rangaraj. I'm the program manager for the product management team. And today I'm going to briefly talk about the OptiScript interface updates for the version 2022.1. Here is an agenda of presentation. So I'm going to go over these features briefly. Adaptive perfectly matched layer. This is one of the important method in exterior acoustic analysis for defining sound propagation in unbound domains. Added a new element type as part of the interface update. More information about these elements and the respective properties can be found in our solver documentation. To define a free convection. So convg is the bulk card, and this bulk card is added as part of the and we also have convg add in case of defining the combined convg, and convg can be referenced in the subcase selection define subcase dependent reconvection definition. And this is how the card definition is there. And in the conventional way, NASTN compatible way, we used to define multiple solver cards earlier. Even now we support these definition. However, the new way of defining the convection is much simpler compared to the convention NASTN convention way. If you could see the NASTN convention way, we have multiple solver cards involved here. So we have defined the CHDY to define the convection surface, the conv, and the pconv, and the ambient temperature are defined through the SPC, and so on. You could see these are the list of cards required to define a convection, the NASTN convection way. The new way of defining the convection with regard to convg, it's much simpler, and everything is defined in one single card. So this is much beneficial compared to the conventional way of doing it. So this feature is available as part of the code creation from the Solver browser. CA fluid is basically a 1D heat flow elements where you could define the heat flow between the surface and a set of grids which are defined through the 1D elements, and these elements are like the CA fluid. So in heat flow, CA conv is a bulk card where we used to define the 1D heat flow between the surface and the 1D elements. So here we could see the conventional way of modeling it, where I had hand. And another important um, enhancement is about pressure penetration. So pressure penetration load is to define or simulate the fluid penetrating through the surfaces on a contact interference. So there's a new bulk card, press pane, to define the pressure penetration load, and this is how the load the definition looks like in the entity editor. And we also have a respective a subcase selection card and in the subcase nonlinear subcase type. And with regard to the pressure penetration, we also added solver specific model checker checks in the model checker browser. So these are the checks which are already available for the pressure penetration. And one other important enhancement is the shell to solid connection. So RSS con is the NASTN way of defining the shell to solid connection, but again, this card has multiple limitation. So the new card is the RSS con 1. This is a bulk card where you could define the shell edge and the solid phase. And this is how the card definition looks like. And this is supported via entity editor. And we also have the review capability to review the shell to solid connection here. Combined joints, as we are progressing with every release, we have been enhancing the joint G definitions within OptiScript interface. As part of 2022.1 release, we have added these many list of combination joints. I've listed those combination joints here along with the description. And these joints can be defined via panel. So since panel is moving out, so now this can be created via entity editor through the search toolbar. And once you create it, I mean, user have the flexibility to change the type of joint in the entity editor while editing the elements. So what I show you here in this image is the type is editable field now. Once you change the type, the appropriate node IDs and the system selections are updated appropriately. Sensor update. So user can define sensor-based input in OptiStruct. So right now we have the sensor bulk card, which is added as part of the sensor entity. And we also have the sensor add to define the union of several sensor inputs. And these sensor input can be defined in different contexts. What I show here in the image is with regard to the temperature context, which can be used to define the thermostat input. So we had multiple requests to handle the preserved nodes. The preserved nodes are nothing but the grid information which are there in the solver deck, which doesn't have any reference to elements or loads or any other bulk cards or solver cards. So we term them as preserved nodes. So we used to preserve the nodes during the import. Right now, user have the option during import to handle these nodes. They have an option to preserve those nodes or read them as a temp nodes, or we could just ignore those nodes. So these options are provided in as part of the solver options during import. And another key infrastructure enhancement is free format export option for includes. We already have this option for the regular export. Now, if the user wants to export and include in desired format, so now we do support this as part of the include files. So we do have an option over here. By default, this is turned off. If user wants to export and include in free format, then user can turn it on and then export. So whenever this option is turned on for a particular include on export, those includes will be exported as free format. I think that's pretty much what I have to cover today, and thank you.
We have our next presenter with us, Dilip Ram.
Just to introduce myself, I'm Dilip Ram. I'm product manager for solver conversion across interfaces, ANSYS and Paramas interface. As part of 2022.1 enhancements, I will go over the major enhancements done in the conversion as well as ANSYS interface. Before I get into the enhancements for 2022.1, I would like to give a very brief introduction to solver conversion. There are two ways. If you're looking, as you can see it in the images here in the first slide, there are two different ways in which user could make out what we convert and what we do not convert when I do a conversion from one interface to another interface. At first level, we tell the user these are the things supported. And at the end of conversion, we have a very detailed HTML report, which also gives an unsupported list to know the user, which is not supported at the end of conversion. So this is something we are trying to improve and extend it across interfaces. Today, this HTML support is available for Abacus to OS and Dyna to Radios conversion. And our major enhancements in solver conversion across interfaces has been focused on these physics. For Abacus to OptiStruct, as you know, from nonlinear static to heat transfer analysis, we have got good results, and there were good feedback from the customers on running these conversions. Similarly, for ANSYS to OptiStruct, of late, this is picked up from version 2020, where we've got a lot of requests and feedback from the field to improve the conversion related to ANSYS to OptiStruct. So today, with normal modes and linear static analysis, we've got good results. For Radios to OptiStruct, with OptiStruct explicit evolving, I mean, this is one area which we are improving in every release. And some enhancements have also been done with PAMCrush to Radios conversion. So in 2022.1, we have enhancements on these conversions for Abacus to OptiStruct, Radios to OptiStruct, ANSYS to OptiStruct, Abacus to Radios, and PAM to Radios. I mean, I will briefly cover the major enhancements done on these conversions, and I would request field or the field to look at the release notes to go over every enhancement done as part of the conversion. The first major enhancements done with regard to Abacus to OptiStruct is related to star cohesive section. So I have a small video here which basically gives you an insight into the workflow as well as how it's converted. So I have a cohesive model here with cohesive elements in the Abacus interface, and these cohesive elements are assigned to cohesive section with the cohesive material mapped to that property. As you can see, the red portion between these two components is the cohesive section or the material. I have a very basic setup here with constraints on one end and the C load on the other side. So we have the conversion from the file pull down menu. So once I run the conversion, as I mentioned in the first slide, we have a detailed HTML report. So where we give out what we convert at the end of conversion. So if you can look at it in the group, we have the contacts, material, adhesive material, which is converted to M cohead. And we also show the element conversion, which is COH3D8 in Abacus to CIF hex in OptiStruct. And we also ensure we have proper results at the end of conversion. So we run a small benchmark and we were able to get fairly decent or close results to Abacus, and so that this could be incorporated. And next other important request which was coming from the field is converting the hyperform material, especially the biaxial, uniaxial, and planar test data. Normally the test data is huge, which runs it to hundreds of lines. And this was very difficult to manually edit it and run it in the solver. So what we do as part of conversion is we map it to relevant OptiStruct cards, which is tab 1, tab 2, and tab 4, which is linked to MAT HE, which is the hyperelastic material in OptiStruct. So if you look at it, Z8 is a hyperelastic material. If I do an XREF on this, you will see the list of curves, which is nothing but uniaxial, biaxial, and the shear test data mapped to this material. Moving further, there has been a lot of emphasis on radius to OptiStruct going as Explicit is evolving. We never had a decent conversion from radius to OptiStruct. So in 2022.1, we have ensured the basic loads and the contacts are converted and the respective load step is created with relevant fields mapped to it. So in this small model, if you can see, I have a type 24 contact. And I have some boundary conditions and C load. Let's run the conversion. So at the end of conversion, we also create the respective OptiStruct cards like D load, T load, which could be mapped to this subcase. So post conversion, if you look, we have the contact converted to auto contact. Since the complete model is part of it, you would not see anything there because we are converting it to auto contact or OptiStruct explicit. And we create the relevant load step inputs like T load and combine those T loads using D load, which is in turn mapped to the explicit subcase. So D load and species are mapped with NL out card created as it is a mandate card for an OptiStruct explicit. Moving further. And one other important thing with RAD to OptiStruct is converting this plastic material. Strain dependent material was a painful task to do it manually. Now we have that conversion supported. We convert it to MAT S1 table MD. And we also ensure the order in which those cards have to be created in OptiStruct is taken care. And there are other enhancements in Abacus to radios. We have some connector sections. supported, and there were a few enhancements for PAM2RAS. And I mean, that comes to an end of solver conversion. Let me go to the next part, which is ANSYS interface enhancements for 2021. Just to give you an overview of what is there in ANSYS interface, one is we have migrated contact surface to set segment. Second, we have supported import of unblocked format material real block loads and systems. And most of the decks with the pressure and temperature load from ANSYS APDL were written in the block format, which was never supported in HyperMesh. And this is again is supported as part of 2022.1. And one major request from the field is to have an embedded entity editor as part of context load step is also supported. And as part of generic enhancements, this has been done across interfaces. One is which is the system creation from the context. And just to give you an insight into what exactly is the difference in the contact card, once we export from 2022 and 2022.1, I have a small snippet. So as you can see here, it was contact surface earlier. Pay attention to the name here, type 2 real mat. This is something which we get on creating this contact through auto contact, which was very difficult to identify in the deck once we export it out in 2022, as we were writing it as HM_comp. Just exporting this deck. So as you can see here, we used to write out contact surfaces with HW_comp with the name and the ID. So even our regular components, or which is mapped to where we have direct assignment today, is also HW_comp, and even the contact surfaces were exported with HW_comp, which made it very difficult for user to distinguish between the component and the contact. And if you look on one other thing which you could look at is there is no group comment. So with the group, user could easily identify which are the contact surfaces or set segments mapped to it. This is enhanced as part of 2022.1. But this is the same model in 2022.1. So this, as I said, we have supported an embedded entity editor where I could pick the faces, add elements directly from the contact, which was not possible in 2022. I could change the element type. I could update the property. This is possible with the new release. As I said, now I could easily distinguish between HM_comp and HW_contact. So as you can see, you have HW_cont ID is equal to 2. At the same time, I have the group comment, which basically has the main and the secondary ID. So name, main ID 2 and secondary 3. So this is the major difference between the exported deck with the set segment migration in ANSYS interface for 2022.1. Yeah. Yeah, thank you all.